In this video, I'm going to look at a quick little JavaScript program that plays around with the Collatz conjecture. So it's not going to really do any real work towards it. It's just more of an example of a while loop nested inside a for loop and a little bit of JavaScript fun. Okay. So I've made I'm in Visual Studio Code. Made a simple little web page here. And so I'll tell you what the Collatz conjecture is. So you start with some integer that is greater than 1, and you apply the following rules repeatedly. And you say that if the number is even, then you will divide it by 2. And if the number is odd, then you will multiply it by 3 and add 1, and then you just you get a result and you keep applying that procedure to what you get. And so I'm just going to call that a chain or a Collatz chain. I don't know if that's a real term, but that's what I'm going to call it. And the idea of the conjecture is that all such chains lead to 1. And then I'm going to just not put it to any kind of real test whatsoever, but I'm just going to show that for the numbers from up to 100, I'm going to start with 2, then for the numbers from 2 and up to 100, that this is indeed the case. I'm going to display the results on the page. And here is a div in which I'm going to put my results when I get them. The rest is a script. So that's the last. So these words are the last things that are hard, in design written on the page. Everything else that you'll see written on the page when you're done was written by code and written into this div. So we start the script. I'm just going to set up a for loop where I'm going to work with the numbers from 2, and I just decided to go up to 100. And I'm going to keep I as it was so I don't throw off my for loop counting, and I'm going to get a variable I'm going to call x for working with as the Collatz integer then to start, and so I'm setting x equal to I. But again, I'm going to change x, but I don't want to change my I because I need to increment it and get through my for loop. I'm going to have divs inside my div. So I'm going to have nested divs or child divs. And so I'm going to, this div does not, the inner divs don't exist. So I'm going to create a div. I'm going to have a bunch of divs, 99 divs. So I want to separate them. So I have given my div that I just created that's not on the page yet, I'm giving it a border style of thick solid black. So it will be very obvious where the divs begin and end. I'm giving it some padding, so there'll be a little space all around it. And I'm starting off the first thing I'm writing into my div is I, and this could have been X because X and I are the same. Okay, so I'm just starting off with the integer, but now I'm switching over to the X, and here's my main Collatz chain creating loop. Again, I don't know how many times for a given X, I don't know how many steps of this Collatz procedure that I'm going to need before I hit 1. So that's a while loop. Okay, when I know how many times, if I know I'm going to start at 2 and end at 100, then I'm using a for loop. But this, I don't know how many times I'm going to be in it, so I'm going to use a while. And my condition is so long as the X is not equal to 1. And I need the X's to remain integers. If I do any kind of a division and end up with floats, which is not going to happen here, but if that were to happen, then testing equality or inequality can be a little bit dangerous if these were floats, but these are integers. Okay, so here we go. So if it was an even number, so if x, and I'm going to take the modulus, so I'm going to divide by 2 and take the remainder. So if I divide by 2 and take the remainder, if I take the modulus 2 and that equals to 0, in other words, if x is even, then I'm going to divide x by 2 and make it the new x. Otherwise, if it was odd, I'm going to multiply by my x by 3, add 1 and make that my new x. And I'm going to add that current x to my chain. So I'm doing plus equal, appending to what I've already got in my div inner HTML. And this is a non-breaking space. This is the HTML entity for a right arrow, another space, and I'm adding the x. And then I'm adding, this is a space as opposed to a non-breaking space. So I break. I shouldn't get any breaks here, but I can get, after I have the number x, I shouldn't get breaks. I shouldn't get any break here, but I should be able to get breaks here. We'll see if I remember, we'll see if that's the case. Okay, and then when the loop is done, I'm done with that particular div, and I add that div to my page. And then this is my for loop, okay? And it's just going to do it. There's no buttons that I click to start this thing. It just starts it from the beginning. And okay, so that's the whole program about down at the bottom. So let's run it with a live server. And then we see here's what we generated. So if I had a 2, I divided by 2 and immediately got 1. If I had a 3, I multiplied it by 3 and added 1, that got me 10. If I had 10 is even, so I divided it by 2 and got 5. That was odd, so I multiplied it by 3 and added 1, that got me to 16. And then once you get to any power of 2, it's just divide. So divide by 2, divide by 2, divide by 2, divide by 2. So that's always, that's always a quick path to ending. Okay, so that's the game. We see the right arrows that we produced. We see down here that some of the chains are long. 27 is a pretty long chain, and we see here that we tend to end in numbers. So we are playing that non-breaking space game. Here's 32, a power of 2. So that was a very short chain. And I'm not going here for efficiently testing the conjecture, because once, if say I've done up to 10 and I've tested that, then I know anytime I get down to 10, I can stop there. So I can stop at the lowest number that I've tested up to. So my while condition is inefficient. I don't have to go all the way down to 1. I could really go down to, I would say, I-1 if I wanted to make a more efficient test of the Collatz conjecture. But I'm not really testing it in any serious way. I've only gone up to 100, but it was just a simple little sort of intro program with nested loops, a while inside of for, a bit of fun. That's all I wanted to show you. Thanks for your attention.